Hello everyone, welcome to Malaysia Online Tuition YouTube channel. In this video, we are going to be looking at A-Level Pure Mathematics 3 Complex Number Review Part 1. If you like and enjoy watching this video, please give us a thumbs up. If you want to receive updates on our newest video, then please hit the subscribe button as well as the notification bell so that you won't miss any of our future videos. Okay, so before we start, I would like to mention that we also provide tutoring, private tutoring for pure maths, for maths 9709, and then also for physics 9702, and also chemistry 9701 and biology 9700. So for the first question, on an Argand diagram, sketch the locus representing complex number z satisfying modulus of z minus 2 equals 2 and the locus representing complex numbers w satisfying argument w plus 3 minus I equals 1 over 4 pi. Find the least value and greatest value of modulus w minus z for points on this loci. Okay, so now we have to sketch first these two locus. Okay, so now we know that the first locus is going to be a circle. The center is 2, 0, and the radius is 2. And then the next locus is going to be a half line, okay, with the center, okay, or we are going to sketch it from what? -3 and then 1. And then the argument is going to be 1 over 4 pi. Okay, so we are going to start with the circle first, the easiest one. Okay, so this is the imaginary axis and this is the real axis. So now the center of the circle is going to be 2, 0. So let's say 1, 2. Okay, so let's say 2 is somewhere here. And then this is the center. And then we are going to take 2 units to the left, 2 units up, 2 units down, and 2 units to the right. Okay, done. And then we can sketch the circle. Okay, I think I overshoot the scale a little bit. Yeah, I think so. Okay, wait. Okay. Alright, so we can fix this now. Okay, so this is the locus of our circle. Okay, so we can erase this as well. So now for the half line. Okay, so the half line we are going to sketch from, -3, 1. And then the gradient is 1 over 4 pi. Okay, so how are we going to know where is it going to be passing? Okay, so this is very simple. You know that we have the formula gradient equals tan theta. So the gradient is going to be tan pi over 4, which is actually 1. Okay, and then we can find the equation of the straight line, okay, or this half line. So y minus 1 equals m, and then x plus 3. Okay, the gradient here is 1. So then we expand, we get what? X plus 3 plus 1. So we know that the y-intercept of this half line is going to be 4. Okay, so where is -3, 1? Okay, let's check. So -1, -2, -3. Okay, so somewhere here. And then 1, we can say somewhere here. So this is the point where we are going to sketch the half line from. And then, like I said, we have the y-intercept to be 4, right? So where is 4? 1, 2, 3, 4. Okay, let's say 4 is somewhere there. So it is going to be something like this. Okay, that is the half line. Okay, so now the question is, we want to find the least and greatest value of modulus w minus z. Okay, meaning the shortest distance and also the longer distance. Okay, so now what we have to do is, you have to understand that the shortest distance is going to be the perpendicular distance. Okay, I'm going to use another color here. So we are going to connect the center of the circle to the half line here, okay, and make sure that this is perpendicular like this. Okay, so now what we need to do is we need to find what is the intersection point between the blue line and the red line. Okay, and then the shortest distance or the least value of modulus w minus z is going to be this one, as you can see, least. Okay, and then the greatest, of course, you are going to go until the end here. Okay, but we are going to discuss it later. We just need to find the least value first. Okay, so we have the equation of the half line, and now we need the equation of the blue line. So how to find the equation of the blue line? Okay, we know the gradient must be, product of the gradient must be -1. So we can say m1, m2 equals -1. So the gradient of the red line is 1. So then we have the gradient of the blue line to be -1. Okay, done. And then we know that the point that the blue line passes through is going to be the center of the circle, which is 2, 0. So we can establish y minus 0 equals -1, x minus 2. Like this, okay? So y equals -x plus 2. So this is the equation of the blue line. So now we can find the intersection between the red and the blue line so that we know the point that they intersect, and then we can find the shortest distance, just like that, okay? So now, equating the two equations, x plus 4 equals negative x plus 2, and then shifting, we get what? 2x equals negative 2, so x equals negative 1. Okay, so now we know the x coordinate, we need to find the y coordinate. So y equals negative 1 plus 4, so we get y equals 3. So the point of intersection, POI, is going to be negative 1, 3. Okay, so what now? We need to find the distance between the center of the circle to the point of intersection, and we know the radius of the circle is 2, right? So the radius of the circle is 2. So if we want to find the least, we need to subtract the distance of the point of intersection to the circle, okay, and then we minus 2, the radius, and then we want to find the greatest value, we need to add 2. Okay, like that. So now let's work on the distance between the point of intersection and the center of the circle first. So we can call this to be point A, and then we can call the center of the circle to be point C. Okay, so now the distance AC, okay, we can say like this, equals square root of, so this is 2, 0, so we can say negative 1 minus 2 squared plus 3 minus 0 squared. So this is equal to what? 3 squared, so square root 18. So this is 3 square root 2. Okay, this is the distance of AC. So to get the least value, okay, so I think we can conclude now. So least modulus of z minus w, it is w minus z, okay, it's the same thing lah, okay. W minus z equals 3 square root 2 minus 2, like I said, minus the radius. And then for the greatest, we just have to add 2. Greatest modulus of w minus z equals 3 square root 2 plus 2. That's it, okay? And that's all for this first question. Next, for question number 2, given that z is a complex number, find z in the form x plus yi such that 18 minus 6i equals 4z conjugate minus 2zi. So for this question, we can straight away write 18 minus 6i equals 4, and then z conjugate, okay, so since z is x plus yi, we can say that z conjugate is x minus yi, and then minus 2, our z is x plus yi, and then multiplied by I. Okay, so then expanding on the right hand side, we get 4x minus 4yi minus, okay, x times I is xi, so minus 2xi, and then yi squared, negative 2yi squared. And then on the right, we have, okay, so negative 2yi squared is going to be positive 2y, so we can group the real parts together, so 4x plus 2y. And then for the imaginary parts, we can say minus, and then 2x plus 4y, we put the I behind, like that, okay? And then 18 minus 6i on the left-hand side. So now, since we group the real parts and imaginary parts on the right-hand side, we can equate the real parts on the left and right, as well as the imaginary parts on the left and right-hand side. So 18 equals 4x plus 2y. So we can divide by 2 for everything. So we get 9 equals 2x plus y. So this is the first equation. And then from the imaginary part, we can get from the left, negative 6 equals negative of 2x plus 4y. Okay, so as you can see, we can just cancel the negative. So we have 2x plus 4y equals 6. So even though we can make this smaller, right, but I think that we can just substitute y, okay, inside the second equation later. So y equals 9 minus 2x. So we can say this is the third equation. So sub the third equation into the second equation. So we get what? 2x plus 4. So our y is 9 minus 2x equals 6. So we get 2x plus 36 minus 8x equals 6. So shifting the 36 to the right hand side, okay, 2x minus 8x equals negative 6x. 6 minus 36, that is going to be negative 30. And then x equals 5. Okay, we can cancel the negative. And then for our value of y, we get y equals 9 minus 2 times 5. So this is 9 minus 10. We will get negative 1. Okay, so for the final answer for our z, that is 5 minus I. Okay, so how do we check our answer here? So using our calculator, we go to the complex mode, and then you write down the right hand side okay, for example 4, and then our z conjugate is going to be 5 plus I, okay, like that. And then minus 2, our z is what? 5 minus I, so we write 5 minus I, and then we multiply it by I. And then if we get the original complex number on the left, which is 18 minus 6i, meaning that our z is correct. So as you can see, we get 18 minus 6i, which is what we have on the left hand side. So this is the final answer for question number 2. Now for question number 3, find the square roots of negative 12 plus 5i in the form x plus yi. Also, find the square roots of 3e to the power of I pi over 4 in the form rei theta. For the first question, we have the square roots of negative 12 plus 5i, okay, and this is equal to x plus yi. So what we can do now, we can shift the square root to the right hand side. So we have negative 12 plus 5i equals, okay, so this is going to be x plus yi bracket to the power of 2. So when we expand the right hand side, okay, this is the simplified answer straight away. We will get x squared minus y squared plus 2xyi. Okay, so you should be able to prove that the expansion of this bracket is going to give you this. So now comparing the real parts and the imaginary parts on the left and right hand side, we have x squared minus y squared to be equal to negative 12. And then for the imaginary part, we have 5 equals 2xy. So now we can replace our x or y, okay, up to you. So let's say we replace our x equals 5 over 2y. Okay, so now substituting inside the real part, we have 5 over 2y squared minus y squared equals negative 12. And then expanding, we get 25 over 4y squared minus y squared equals negative, negative 12. Negative 12, okay, we haven't multiplied yet. Now we have to multiply by 4y squared, okay, to get rid of the denominators. So we get 25 minus 4y to the power of 4 equals negative 48y squared. So shifting everything to the right hand side, okay, we get 4y to the power of 4 minus 48y squared minus 25 equals 0. Okay, so let's try to factorize this. So this is, we can try this to be 2y squared and then 2y squared. And then let's say this is 25 and then this is 2. So you can see that we want negative 48, right? So this is going to be negative. This is going to be positive. So 2y squared plus 2 equals 0 won't have any solution because this will give you imaginary solution. So now we are going to take 2y squared equals 25. Y squared equals 25 over 2. And finally your y is going to be plus minus 5 over square root 2, which in turn will give you plus minus 5 square root 2 over 2. Done. Okay, so now we can substitute. So when y, okay, equals 5 square root 2 over 2, what is our x? 5 over 2, 5 square root 2 over 2. So we can see that we can cancel this and this, this and this. So this is 1 over square root 2, which will give you square root 2 over 2. Okay, so for the y, negative 5 square root 2 over 2, you are going to end up with the same thing. It's just that your x is going to be negative only. Okay, that's it. So we can just straight away write negative square root 2 over 2. So the two square roots of the complex number negative 12 plus 5i is going to be negative square root 2 over 2 minus 5 square root 2 over 2i. Okay, this one. As well as square root 2 over 2 plus 5 square root 2 over 2i. Okay, so now how to check our answer? Okay, very simple. Okay, from your calculator, you type the complex numbers that you have, okay, the square roots of the complex number just now. And if you get back what you have before square rooting, that means your answer is correct. Okay, so let's try that. Negative square root 2. And then we can just combine them. Okay, so minus 5 square root 2i. Okay, wait. Negative square root 2 minus, okay, wait, I forgot to put a bracket. Sorry, bracket is very important here. Okay, so negative square root 2 minus 5 square root 2i over 2. And then you put the squared outside. And then as you can see, we get the original complex number again. So this means that our answer, the first square root just now, is correct. Okay. So then, when we change this to plus and this one positive, we also end up with the same answer. So we have confirmed that these two are the final answer for the first part of this question. So find the square roots of 3e to the power of I pi over 4 in the form re I theta. Okay, so what about this one? Okay, meaning they ask us to find the square root of the exponential complex number here, meaning the complex number is in exponential form, and they also want the answer in exponential form. Okay, no problem. So let's say that is going to be w, okay, equals 3e I pi over 4. So when we are finding the square root of w, right, okay, so we can first find the modulus of square root w. That is going to be square root of 3. Okay, done. So now for the argument is the problem here. Okay, so for the argument, what you can do is you can use a formula, okay, to find the argument of the two square roots here. Okay, so the argument formula is going to be something like this. Okay, so we can write w square root of w, right? Yeah, the two square roots, okay, is square root 3 e I, okay, and then you open a bracket, and then you can write the pi over 4, which is the original argument, and then you have to write plus 2 pi k divided by n. Okay, so the k is the root. Okay, for example, you have the two square roots, right? So the k is going to be starting with 0 and then later 1. Okay, so if you have two roots, right, then you are going to write 0 and 1. If you have 3, for example, you want to find the cube root of the 3e I pi over 4, you are going to have 0, 1, 2, and so on. So the n here is going to be, for example, you are finding the square root 2, cube root 3, and the fourth root 4, and so on. That is the value of n. Okay, so now starting with the value of k0, we get square root 3e and then I. What is this? Pi over 4 plus 0 divided by 2, because we are finding the square root. So this is square root 3e I pi over 8. This is the first answer. And then for the second answer, we use k equals 1. Square root 3e I pi over 4 plus 2 pi divided by 2. So what is this? Pi over 4 plus 2, that is going to be 9 over 4. So 9 over 4 divided by 2, that is 9 over 8. Okay, so we can write square root 3e I 9 over 8 pi. But wait, before you say that this is the final answer, please realize that the argument must be between negative pi until pi only, right? So as you can see, 9 over 8 pi is already exceeding the range of this argument. So what we need to do is we need to do 9 over 8 pi minus 2 pi. So this is 9 over 8 minus 16 over 8. That is going to be negative 7 over 8 pi. So instead of writing 9 over 8 pi for the argument, you are going to write square root 3e I negative 7 over 8 pi. Okay, this is what you should write. Okay, so for the final answer, for the square roots of this complex number 3e to the power of I pi over 4, it is going to be square root 3e I pi over 8 and square root 3e and then I negative 7 over 8 pi. Okay, done. So now for the part where you need to check your answer, right, in the exam later. So what you can do is something like this. So this is going to take some time, okay? So for the w, right, w here, I'm going to write this in the polar form, okay, or we can say the modulus argument form. So this is 3 and then cos pi over 4 plus I sine pi over 4. So what is this? Square root, pi over 4, cos pi over 4 is square root 2 over 2. So this is 3 square root 2 over 2 plus 3 square root 2 over 2i, okay? So what we are going to do is the same like what we have done for the previous question just now. We are going to check whether when we square the square roots that we, the answer that we have just now, we are going to get this again. Okay, so let's check first. Square root, 3 square root 2 over 2. What is the value? 2.121, okay? So please remember 2.121, this value. Okay, so now let's check. So we change the answer to the polar form as well. So we can write square root 3 and then cos pi over 8 plus I sine pi over 8. And then for the second answer, we do the same. And then cos negative 7 over 8 pi plus I sine negative 7 over 8 pi. Okay, let's check. So now we can write square root 3, and then open bracket, cos pi over 8. Okay, or if you want to make it simpler, right, you just keep the pi over 8 inside a letter, for example. Pi over 8, and then you store inside A, and then you put negative 7 over 8 pi, and then you store inside B, for example. Okay, so now we can write square root 3, oh yeah, inside a bracket, by the way, square root 3, and then open bracket, cos A plus I sine A, like this, close bracket, and then close another bracket squared. As you can see, when you square, right, the bracket just now, you get 2.121, okay, and then plus 2.121 I, meaning the blue color. Okay, so now we are going to repeat the same thing, but using, okay, wait. We are going to use, wait. Oh, we cannot change. We need to rewrite everything, okay? Square root 3, and then cos B, now B, right? Because negative 7 over 8 pi. And then plus I sine B. Okay, close bracket, and then close another bracket squared. As you can see, you end up with the same answer. 2.121 plus 2.121 I. Okay, so we have verified that both of these answers are correct. Okay, so this is the final answer for question number 3. Moving on to question number 4, given that Z equals 3i over 1 plus 2i, W equals 5 plus I, and V equals negative 1 plus 4i, find the modulus and argument of the following complex numbers for part A, Z to the power of 4. So for this question, right, instead of finding Z to the power of 4, meaning you find the complex number and then you find the modulus and argument, what you can do for this question is you can change the Z, W, and V into exponential form first before you answer question part A, B, and C. So for complex number Z, we can find the complex number first in the form x plus yi, and then we change to exponential form. So 3i over 1 plus 2i, and then we multiply by 1 minus 2i over 1 minus 2i. So what is this? 3i minus 6i squared divided by 1 minus 4i squared. So then we have our z to be, this is negative 6 times negative 1, which is 6, plus 3i over 1 plus 4, that is 5. Okay, and then we can change this into the exponential form by first finding the modulus and argument. So we can say that this is square root of 6 over 5 squared plus 3 over 5 squared, and then we square root the sum. Okay, so I can write this as 6 over 5 plus 3 over 5i. So what is this? So square root of 6 over 5 squared plus 3 over 5 squared, and then we square root the sum, we get 3 square root 5 over 5. Okay, done. And then for the argument of z, what do we get? So since this complex number, right, the 6 plus 3i is in the first quadrant, we can straight away use tan inverse of imaginary over real, which is what? 3 over 6. So what is this? So tan inverse, okay, make sure you calculate it in radian mode, 1 over 2, okay? So we get 0.4636, okay, we can just use 0.464 radians, okay? So before you proceed any further, please check whether this is actually your modulus and argument, okay? So how to do that? You go to shift menu, and then you go to complex number 2, and then you change into the second form. Okay, and then what do we write? Go to complex mode, 3i over 1 plus 2i. Okay, as you can see, we get the modulus to be 3 square root 5 over 5, and then the argument to be 0.464. Done. Okay, and remember that you just have to do this once, okay, for each complex number before you proceed with A, B, and C. Okay, so next, we can find the for W, right? So 5 plus I, so as usual, the modulus, so this is going to be square root of 5 squared plus 1 squared, which is square root 26. And then the argument of W, we have tan inverse of 1 over 5, and what is that? So tan inverse 1 over 5, we get 0.197 radian. Okay, done. So let's check again whether this is correct or not, the modulus and argument. So 5 plus I, we get square root 26 and then 0.197. And then for the last one, we have v, and that is negative 1 plus 4i. Oh yeah, by the way, I forgot to mention that we are using this formula because 5 plus I is also in the first quadrant. But for v here, you can see that we have this to be in the second quadrant. So when you are finding the argument later, okay, please don't forget to consider that complex number v is in the second quadrant. So the modulus is going to be square root of negative 1 squared plus 4 squared. So this is square root 17. And then for the argument, remember, formula for the second quadrant is pi minus, okay? Pi minus tan inverse of 4 over 1. So what is this? Pi minus tan inverse of 4. So we get 1.816 radian. Okay, and as usual, let's check. Negative 1 plus 4i, we get, yeah, square root 17, 1.816 radian. Okay, so after we found everything, okay, we can write them in this form. Okay, like I said just now, we write all of them in the form of exponential form. So z equals 3 square root 5 over 5 e, and then I 0.464. And then for w, we have square root 26 e, and then I 0.197. And finally, v, we have square root 17, and then e, I 1.816. Okay. So now we can start the question. Okay. So for z power of 4, what we can do is we power of 4 the modulus. So we can write that 3 square root 5 over 5 to the power of 4. And then e, I, so the argument we multiply by 4. Okay. So what is this? So as you can see, the process of getting the modulus and argument is now easier when we have the complex numbers to be in exponential form. So we can write 3 square root 5 over 5 to the power of 4, we get 81 over 25. And then e, what is this? 4 times 0.464. We get 1.856. Okay, so I 1.856. Okay, done. Okay, so remember to always check whether your argument is in the range or not, okay? Because you know the range is until pi, right? So you know that the value of pi is 3.141. So this is in the range of the argument allowed, okay? So we can say that the modulus of z power of 4 is 81 over 25. And then the argument of z to the power of 4 is equal to 1.856. Done, okay? So that's all for question part A. For part B, w squared v squared. Okay, no problem. So for w squared v squared, we are going to square the w and then square the v as well. So we can write square root 26 squared. And then ei, we multiply the argument by 2. So 0.197 times 2, we get 0.394. And then remember, we multiply square root 17 squared, and then ei, the v we have to multiply by 2, the argument. So we get 3.632. So remember that when we multiply, right, the e is going to be, the powers of the e is going to be added. So now what do we have? Square root 26, 26 straight away, okay, times 17. We get 442. ei, so 0.394. Plus 3.632. Okay, later I'm going to teach you how to check the answer. Okay, so this is 4.026. And like I said just now, always check the argument whether it's in the range or not. And we know that this is already more than pi. So what we need to do is we write 4.026 minus 2 pi. So that is in the allowed range. So 2 pi minus answer we get, 2 pi minus instead. Okay. 4.026 minus 2 pi instead. Okay. So, oh no, we have to go back like this. So 4.026 minus 2 pi, what do we get? Negative 2.257. So now we can write this as 442 e and then I negative 2.257. So the modulus w squared v squared is going to be 442, whereas the argument is going to be w squared v squared is negative 2.257. I think it's time for us to check the answer before we proceed with part C. So go to complex mode. And then just now we have the z, right? So what we are going to do now, we are just going to write 3i. Okay, no, not 3i. Wait. 6 over 5. 6 over 5 plus 3 over 5i. And then you power of 4. So as you can see, we get 81 over 25 for the modulus. Okay, and that is correct. And then the argument is 1.85 or 856. It is 855. Okay, so we have to correct this. Okay, 1.855. Okay. Okay, but it's not that. Oh wait, if we round both of them, we get 1.86, right? Okay, so I forgot the answer must be in 3 significant figures. Okay, 1.86. This one as well. Negative 2.26. Okay, so now let's check the answer for this one. So what do we have there? W squared v squared. So we go back to the original complex numbers. So 5 plus I squared and then negative 1 plus 4i squared. As you can see, we get 442. Okay, 442, done. And then negative 2.26, done. Okay, correct argument as well. And for the last one, which is part C, ZWV. So what is ZWV? We are going to be multiplying all the exponential form just now. So we have 3 square root 5 over 5 EI 0.464 times square root 26 EI 0.197 times square root 17 EI 1.816. Okay, so what do we get? So 442, sorry, not 442, square root 26 times square root 17 and then times 3 square root 5 over 5. We get 28.2. Okay, just write like that. And then EI, we add the powers. So 0.464 plus 0.197 plus 1.816, we get 2.477. Okay, done. So now we can straight away write, okay, and by the way, this is in the range that we need, okay. So the modulus of ZWV is equal to 28.2, and then the argument of ZWV is going to be 2.48. Okay, and as usual, let's check the answer. Okay, so like I said just now, we have to write all of the complex numbers together. So 6 over 5 plus 3 over 5i, and then 5 plus I, and finally negative 1 plus 4i. What do we get? 28.2, as I said just now, and then 2.48 radian for the argument. So this is how you solve complex number questions where they ask you to find the modulus and argument of something like this. Okay, so that's all for question number 4. For question number 5, a complex number z satisfies modulus of z plus 6 minus 8i equals 3. Sketch the locus of the points representing z in an Argand diagram. Find for part A the least and greatest value of modulus z. Okay, so for the first step, we need to sketch the Argand diagram first. So the center of the circle here is going to be, okay, we can write here z minus and then negative 6 plus 8i, meaning that the center of the circle is going to be at negative 6, 8. Okay, so we can sketch something like this. Okay, we don't have to write the positive x side at all. Okay, so negative 1, negative 2. Okay, so negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, so just approximate. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay, somewhere here. So this is the imaginary axis. This is the real axis. So then, okay, I have to do this. Okay, and then this is where our point is. Okay, so, okay. So then our circle, the radius is 3. So we are going to take 3 units up, down, left, right. Okay, so 1, 2, 3. 1, 2, 3. 1, 2, 3. No, too far. Yeah, and then 1, 2, 3. Okay, like this. And then this is the equation, the locus of the circle. All right. Okay, so then after we have the circle, we need to find the least and greatest value of modulus z. Okay, so what is the meaning of modulus z? Modulus z is actually the distance of the complex number from the origin. Okay, so now our origin is over there. So now what we need to do is we need to, the center of the circle, by the way. The center of the circle, C is negative 6, 8. So to find the least and greatest value of modulus z, we need to connect the origin to the center of the circle, like that. Okay. All right, like this. Okay, something like that. Okay. I know that it doesn't pass through because of this software, okay, but let's say that it passed through the center of the circle, and then the least value is going to be this one. This is going to be the least value of modulus z, okay? And then the greatest is going to be, you just add the radius later, okay? Because you know that the radius is going to be 3 here and 3 here. So for the least value, you minus 3, and then for the greatest value, you add 3, okay? Just like that. So now, we need to find what is the distance from the origin to the center of the circle. So we can say that modulus of negative 6 plus 8i equals, okay, so negative 6 squared plus 8 squared, we get, this is 100. So square root 100, we get 10. Okay, so the distance from the origin to the center of the circle is 10. So for the least modulus z, okay, it is going to be 10 minus the radius, which is 7. And then for the greatest, wait, why did I write z? Modulus z, by the way. Okay, sorry about that. So greatest modulus z is going to be the distance from the origin to the center of the circle, and then you add 3 instead. So that is going to be 13. So these are all the final answers for question number 5 part A. Next, for part B, the least and greatest value of argument z correct to 2 decimal places. Okay, so now for the argument z, okay, again, argument z meaning the argument of z from the origin. So what I suggest you to do for this question, okay, so in the case of your exam later, you take a ruler, okay, and then you go from the positive real axis, and then you go anti-clockwise until you touch the first part, okay, of the locus, okay, the locus. And then for the greatest value of argument z, you do the same thing, but you are going to go until the last point of the locus, like that, okay? So now you can see that we have the case of the 2 tangents intersecting at one point, which is the origin here, as you can see. So then what you can do is, you can connect the point of tangency to the center of the circle, and then the point of tangency to the center of the circle. And remember that the point of tangency, okay, is going to be 90 degrees to the center of the circle, this one as well. Okay, so now what you need to find is this one. You need to find this, theta, and then you need to find this as well, which is theta. Okay, so the next thing that you need to do is, you need to find what is the argument. Okay, what is the argument of this center of the circle, which is negative 6, 8. And then to get the least argument z, you are going to take the argument of the center of the circle minus theta. And then for the greatest argument, you take the argument of the center of the circle plus theta. Okay, that's why the first thing that we need to do here is to find the value of theta. Okay, so for the value of theta, we are going to sketch a right angled triangle. Okay, so let's say this is the right angled triangle. Okay, like this. Okay, so then the theta that we want to find here is going to be over here. This is the theta. And then this is the 90 degrees. And then we know that the radius of the circle is 3, right? So the 3 is over here. And then the distance from the origin to the center of the circle, we already found that to be 10. So in this case, our sine theta equals 3 over 10. So then our theta, okay, you remember, right? We need our argument to be in radians. So sine inverse of 3 over 10, that is going to be 0.3047 radians. Okay. So before we can find the least and greatest value of argument z, we need to find what is the argument of the center of the circle. Okay, so I can write something like this. Argument of -6 plus 8i. Okay, so how to find this? Okay, first, you need to determine that the -6 plus 8i is in which quadrant. Okay, and as you can see, it is in the second quadrant. So the formula for the second quadrant, okay, I think I taught you this already in the past paper videos, okay, that has been removed. So for the Argand diagram, the first quadrant is theta, the second quadrant is pi minus theta, the fourth quadrant is negative theta, the third quadrant is negative pi plus theta. So our theta is going to be the tan inverse of imaginary over real. So then, since our center of the circle here is at the second quadrant, is in the second quadrant, so we are going to use pi minus theta. Okay, so pi minus tan inverse of the imaginary, which is 8 divided by 6. Okay, always take the positive value for the imaginary and real. So now for this, what do we get? So pi minus tan inverse of 8 over 6, and we get 2.2143 radians. So after we get the argument of the center of the circle, right? Okay, so let me show you where is this argument of center of circle. Yeah, this one. This is the argument of -6 plus 8i. Okay, so after you found that, okay, okay, wait, a little bit more. Like that. Okay, so that's why I said just now, for the least, we need to minus the theta, and for the greatest, we need to plus the theta. Okay, so now for the answer, right? For the least argument z, okay, we take the 2.2143 plus 0.3047. So what do we get? Okay, so we save this 0.047. We get 2.5. Okay, correct to 2 decimal places. So 2.52. Okay, radians. And then for the greatest argument z, okay, we take the same thing. 2.2143, but this time, wait, I just realized, least we minus, the greatest we plus. Okay, all right. So 2.52 we are going to put for the greatest. 2.52 radians here. Okay, and then this one plus 0.3047. Okay, so let's check again. What is the least? Okay, so 2.2143 minus 0.3047. That is 1.91 radians. Okay, so these are the final answers for question number 5, part B. Okay, for question number 6, which is the last question for this video, the complex number z equals I is a root of the polynomial p of z equals z power of 4 minus 6z cubed plus 14z squared minus 6z plus 13. Find the other roots of this polynomial. Okay, so they have given us that z equals I is a root of the polynomial. So using the concept of the conjugate of this complex number is also going to be the root of the polynomial. Okay, so we can say if I is a root, then negative I is also a root. Okay, that's what you do. So now we found the two roots of this polynomial. So what we can do is we can first find the sum of roots. So equals I minus I, which is 0, of course. And then we can find the product of roots, which is going to be I times negative I. And this is going to be negative I squared. And we know that negative I squared is equal to 1. Okay, that's it. So what we can do next, okay, we can use this equation, which is z squared minus sum of roots z plus product of roots equals 0, for us to find the divisor for this polynomial, okay, because we want to find 2 more roots, right? Because z power of 4, meaning we have 4 roots. So if we want to find the other 2 roots, we need to use long division first. So sum of roots is 0, so product of roots is 1, so we can say z squared plus 1 equals 0 is the divisor that we are going to use for the long division. Okay, so for the next step, we are going to do the long division. So z power of 4 minus 6z cubed plus 14z squared, and then minus 6z plus 13. And then we divide this with z squared plus 1. Okay, so this one is z squared. So minus z power of 4 and then plus z squared. So negative 6 z cubed. 14 minus 1, that is 13 z squared. And then minus 6z. Okay, so we multiply by what here? Okay, so we multiply by minus 6z. So we get minus negative 6z cubed and then minus 6z. So you can see negative 6 minus negative 6, which means negative 6 plus 6, we get 0. So now we end up with 13z squared plus 13, and this one, no-brainer, plus 13. Okay, so minus 13z squared plus 13 equals nothing. Okay, meaning that we don't have any remainder. So now we have the quotient z squared minus 6z plus 13 for us to find the remaining two roots. So now z squared minus 6z plus 13 equals 0. So we are going to do completing the square here. Okay, so z minus 3 squared minus 9 equals negative 13. So z minus 3 squared equals negative 13 plus 9, that is negative 4. Okay, so z minus 3 equals plus minus, okay, so you know that negative 4 is going to be 4i squared. So we can write like this, square root of 4i squared. Don't forget the plus minus. Z minus 3 equals, so this is going to be plus minus 2i. So then our z is going to be 3 plus minus 2i. So for the final answer for this question, right, we have our roots to be z equals negative I, because they said the other roots, right? And then z equals 3 plus 2i. And finally, z equals 3 minus 2i. Okay, so what you can do to check your answer, right? For example, okay, let me give you an example. If you want to check your answer, you go to complex mode. You write down the polynomials that you have here. So x to the power of 4 minus 6x cubed, and then plus 14x squared minus 6x plus 13. And then you press the CALC, right? Okay, meaning you put a value inside. Let's say you put the value I, which means the root that we were given in the beginning just now. And then you can see that we get 0. Okay, root meaning that the value must be 0. So then when you substitute the negative I, 3 plus 2i, 3 minus 2i, if you get all of them to be 0, meaning that you have proven that they are all the roots of this polynomial. Okay, so that's all for this question number 6. And that's all for this complex number review part 1. So if you have any question or any comment, please leave them in the comment section below. So if you like and enjoyed watching this video, then please give us a thumbs up. If you want to receive updates on our newest video, then please hit the subscribe button as well as the notification bell so that you won't miss any of our future videos. Thank you very much for watching this video, and finally, please take care, and I hope to see you in our future videos.